we're starting into, oh hey, it's noon on Wednesday. I know. Normally we don't deal with this because we're remote. But today we're starting proofs with triangles. Alright, so before anybody craps a brick, we start off with me giving you all the statements. And then I'm going to stop giving you statements because you're big boys and girls and you guys can handle it. Okay? So, when it comes to the different ways that you can prove triangles congruent, this reference sheet is your new best friend. And if you need like a tab to put in your notebook, like, hey, this is my new bestie, I have tabs. Like little stickums that you can put at the top. Because everything that we do when it comes to these proofs comes off of this page. So, when we're looking at side, side, side. One side, two sides, three sides. Now, side, angle, side, and the ones with the angle start getting really weird for kids just because they're like, well, where does the angle have to be? So, the angle needs to be sandwiched in between the two sides. So when I'm looking at this, I would go side, here's my other side, and then I need this angle in between them. Okay? It's not annoying or anything. Angle, side, angle. What needs to be sandwiched in between? Guys, what's in the middle of the Oreo? It's a side. Okay, so I'm going to just put sides down here just for kicks and giggles. Here's one angle, my other angle. Angle, angle, side. Angle 1, angle 2, and then a side comes after. Now, so far we've done, what, 4 of them? There's really only two other options that we could do. It's angle, 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 but think in terms of equilateral triangles. Those are all similar. They all have all 3 angles, but the sides don't necessarily have to match, right? So that comes into play with similarity. The other one that we have is angle, side, side. Okay? Angle, side, side does not work in the real world. The closest we get to angle, side, side is hypotenuse, leg. And it's right angle, leg, leg, hypotenuse, hypotenuse. Alright, now if you look, it's the right angles that they share. Sides, sides. Alright, now, this is not an option that you may ever write on your test. Second period giggled the entire class because we wrote it on their worksheet. And they're like, yeah, I'm writing S on my worksheet. I'm like, yeah, it's angle, side, side, whatever. That is never an option. So if you get to a test and you're like, angle, side, side. No, it's wrong. Don't write it. Alright? When it comes to your proofs, these are the only options that you can actually fill in when you're doing proofs. These are all your reasons. So if you look at everything that we've done over there, this is all we're really focused on right now. Okay? So this takes everything from there and simplifies it down quite a bit. Alright? Definition of midpoint is a big one. Reflexive property is another one. Like, these are your 2 only options when it comes to proving sides congruent. Alright, when it comes to angles, you've got a whole bunch of different ones. Angle bisector is an easy one because that's typically a given. Alright, I will tell you this segment bisects this angle, and then you need to use angle bisector to tell me something about those 2 angles. Alright, and the last thing we've got is CP-CTC again. Congruent parts of congruent triangles are congruent. So if I know that these 2 triangles are congruent, stop it. I can say angle A is congruent to angle D, and yada, yada, yada. B is congruent to E. Oh, what did you do? Go away. Nobody likes you. Stop. right, and this is just kind of matching what we did the other day. So we ready to actually get into the scary stuff a little? Do some proofs? Alright, so flip it to page. So, if you've got side, 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 first of all, doodle all over the pictures they give you on the proofs. It helps way more than anything else. Okay? Make sure that you're following marking protocols. So, if it's got one dash, it's only congruent to the other one with one dash. Okay? So, if I'm looking at this, I've got AB congruent to DE. I've got BC congruent to EF. And then I've got AC congruent to EF. Once I have all three, then I can say the triangles are congruent. So far, so good? Alright, so looking at the proofs, are we terrified? A little bit. No one died in second period, so we're good. So, first things first, as I'm looking at this, I've got my first given, and it's right here. Alright, now it's PQ and ST. Hang on, I scrolled too far. Close enough. Once you fill in that it is a given, mark your picture. Okay? If you do it as you mark, it makes your life a lot easier. My second one is also what? Given. And that's up here, QR and RT. And then my third one is still given. And all that's saying is R is the midpoint of PS. Okay? So you'll notice every time it says midpoint, I circle the midpoint in like purple, because I'm like, midpoint, different color. So if that's a midpoint, how am I able to say that PR is the same as RS? Guys, what's a midpoint? It's halfway. It splits two things in half, right? That's literally the definition. Alright, so anytime you see midpoint, your next line is probably going to be definition of midpoint. Okay? Now for that final step, it says, okay, fine. How are you able to say that these two triangles are congruent? Well, what did we just find? This one's a side, this one's a side, this one's a side. You're literally just going to write in here, side, side, side. Do we feel like we kind of overcomplicated it a little? Do you guys want to try number 2? All right, give it a whirl. How we doing? Done? Stuck? Unsure of ourselves. We feel like this is the second Monday. Now, on this one, you've got a twofer, okay? K is the midpoint of both of these segments, L, M, and JN. So the first one that they start talking about is this one and this one, JK and KN. So why are those two congruent? What did I just tell you? So what do I write on this line? Yep. Now again, I'm going with LM as my next segment. So I still know that K is the midpoint of segment LM. So what would I write in for my reasoning as to why those are congruent? Same thing. Be lazy. Do your little dashes. So now, my final step's going to be what? What did I find? 3 sides. Just write in. Side, side, side. Now luckily, it tells us at the top of the page all of these are side, side, side. Right? But eventually I'm going to stop giving you that information. Ready for the next page? We're just going to keep doing proofs today. Yeah. I think we get through like 5 pages today. Alright, so for this one, first 2 lines are pretty easy, right? Just my givens. So AC is congruent to AD. Alright, now line 3 is where it gets a little screwy. And the reason it gets a little screwy is simply because that final side is the same side between both triangles, right? So these are one of the easiest lines to write in for a proof. I know AB has to be congruent to itself. That's the reflexive property. So now my final step is just filling in that triangle ABC is congruent to triangle ABD. And that's side, side, side. Kind of weird, kind of not. I feel like we're kind of getting the hang of it, especially knowing that our giant list of things that we need to fill in is probably a lot smaller than I think we realized. Alright, up next. We've got side angle side. Okay? So, first side is what? Pick a pair of sides. Yeah, A, B, and D. Alright. Now the angle that's included, meaning angle in between, because these are different triangles and they're not touching at all, you can write that this is angle B is congruent to angle E. Later on, like when we go down, like some of the kids were freaking out because they're like, I don't like it when it's 3 letters, like it freaks me out. I'm like, okay, fine, label them. Label it angle 1, angle 2. As long as you tell me which angle's which, I'm cool with it. Alright, final side. Yep, BCEF. And then I'm back to triangle ABC is congruent to DEF. Alright. So, do we want to do a proof together? Do you want to try it all by yourself? Which one? Okay. So, start off with what I'm given. I'm given JM. Really? Heard. JM, LN, and that's given. Alright, this is where they kind of started freaking out. JMN, JMN, we listed as angle 1. And then L and M, which is right here, we listed as angle 2. Because they were like, I don't like saying all the letters. I'm like, fine, as long as you label it so I know what you're talking about, that's cool. So, why do I know that those two are congruent? Did it. Alright. MN is congruent to NM. We just did it. What's that called? Reflexive property. Remember how you guys loved yelling definition of congruence? Because you're like, I know definition of congruence. Reflexive property, same deal. Alright, so I have the single side, I have my red angles, and then I've got this side in the middle. What's my reasoning going to be? Yep. Next page. Let's try number 6, and then I'll go back and do 5 with you real quick. So you guys try 6 on your own. How's it going? Good? Stuck? Still working on it? Tell me when. Either ready or stuck. Stuck. All right. So, I got the given, right? It's a midpoint. Now it's a double midpoint again. So remember, the only way I can say WV and VZ are the same is using definition of midpoint. Alright. Now, for this one, they start talking about angles. So I'm going to name it angle 1 and angle 2. Just for the sake of being able to fill stuff in. Okay, so the angles I'm looking at are WVX, so angle 1's right here, and then ZVY, angle 2. What's the relationship between those two? They're vertical angles. Alright, now we come back down here and we're talking about XV being congruent to VY. So remember, they have a double. Okay, it says it's a midpoint of two different lines. So anytime you see this, you need to have definition of midpoint twice. So this one is definition of midpoint. And they are congruent by side angle side. Now that I point this part out, are you guys like, okay, fine, now I know I need to have it twice. Alright, cool. Ready to go back up to 5? Alright, so I have AB is congruent to CB, and that's given. And then I've got BD bisects angle ABC. So, what does a bisector do again? Yeah, it cuts them in half, right? So that means ABD, angle 1 up here, is the same as angle 2 down here. Alright? I don't know about you guys, but I have a horrible time trying to draw the arcs in and make it so you can see, like, this little chunk here is the same as that little chunk right there. Like, it's too freaking tiny. So if I label them 1 and 2, like, okay, 1 is congruent to 2. Sweet. Alright, we good? Definition of angle bisector. What's my next line down? Yep, reflexive. And then line 5. Yeah. Forgot to mark this one. How we feeling? We okay? Are we as terrified as we were when we started? No? Alright, well that's good. Progress. Alright, try number 7. How we doing? I can't tell if the silences were good or I am not okay. Need help with the last part? Alright, so we got the givens, yes? Given. Alright, this one we said was reflexive. And since it's in a side angle side thing, we're here, right? It's just 3 that's kind of screwy, yes? So remember, parallel lines cut by a transversal. What do I know about angle 1 and angle 2? They are alternate interior. So GJH is angle 1. That's congruent to angle 2, and that's because they are alternate interior angles. Better? Yeah, if you see parallel lines, you're probably going to have either corresponding alternate interior or something like that. Like those 3 that had the squiggly bracket from that reference sheet. All right, ready for the next page? Okay, so on this one, your goal at the top is to just kind of go through and tell me, based off just the pictures and the markings that are there, do I have enough info to say that these triangles are the same? Okay, so if I look at number 1, I've got a single dash, I've got the angle, and then I've got my second dash. Single angle, or single side, angle, double dash. So this one's side angle side. Alright, if I look at number 2, I've got onesies, twosies, what about that middle line? Can I say that that middle line is congruent to itself? So this one is now side, side, side. Alright, take a second, see what you can fill in on the rest of them. There are a couple tricky ones, so skip them. But do the ones that you think you've got. How we doing? Good? Stuck? If I scroll down and look at these, how did these go? The bottom ones. We okay? How many of you looked at 7 and you're like, I don't feel like I can say anything about it? Anybody? No? What'd you guys get for this one? So is the angle in between both of those sides? Mm-mm. So you have to take the path of least resistance when you do it. So it's angle here, side, side. This is no bueno. We no can do. All right. What about 4? Yep. Look at the order of those again. Remember, path of least resistance. If I start at my inner angle, going angle, side, side again. Can't do it. All right. Now, 3 is kind of screwy. Because if you look, I've got a triangle here, and then I've got the other triangle here. They share that side. Okay? So that's a reflexive property, and it would give me side angle side. Why would 5 be side, side, side? I can't necessarily say that that's the right angle yet, but I can say that that side is the same as itself. Right? Ready? So, you're going to notice as we kind of keep going down, the proofs are more and more bare. Okay, you want me to do this first one with you? Okay. So, start with your easiest givens. AB is congruent to CD. Given. All right. Now, I'm going to skip around and use different givens at different times. All right. So, I'm going to go straight to D as the midpoint. So, if I know it's a midpoint, what can I say? Yep. I feel like that's a really fancy F. It was not meant to be a fancy F. All right, so the reason I did that is because, let's be honest, this part scares you, doesn't it? So, I'm using what I know right off the bat. Like, okay, this is what I know I can go with. Now I got to deal with the scary one. So, AB is parallel to CD. So remember, my markings are these little arrows here and here. Just forgot that I didn't do it. Now remember, we're going side angle side, right? That was a creepy laugh. So I've got sides. I need to do something with these angles right here. Because remember, the only way I can do this is if I have an angle in between those two sides. Alright? So, want to name them angle 1 and angle 2? So, I've got angle 1 is congruent to angle 2. But why? They are corresponding angles. So I've got a side, got an angle, I've got my other side, I know it's SAS. Now remember, last line, they give it to you, right? So all you got to do is copy this down. Triangle A, B, D is congruent to not as terrible. Try number 10 real quick, without me. How'd it go? All right, you want to start writing in givens for the next one? How did 10 go? Good. How are we doing on 11? Just starting? Before anybody starts erasing, does this have to go second? No. I know, I heard everyone erasing real fast, and I was like, oh crap, no. This one doesn't have to go, like, third or fourth. This one is one of those that you can kind of throw it in whenever you know it. let's be honest, the vast majority of the time, you're going for those easy points, right? So, use my first given, I can go reflexive. The scary part is, I gotta deal with an angle bisector. Like, save that for last. Because the reflexive property has absolutely nothing to do with the angle bisector. Alrighty? I know, we went bell to bell. Alright, see you guys next week.